Hello students, I am doing the second part of this problem, which is actually C and D, which is using the second derivative to analyze the concavity, concave up, concave down, and inflection point. So I have to take the derivative of the derivative, and I decided for some reason to go ahead and simplify this before taking the derivative. I looked at it and I thought, oh, I'll have to do quotient rule and I'll have to do chain. You can do that. I think we did that in class. This is an alternative way to take the derivative of a derivative, is to first simplify it. So no, I'm taking f prime of x, and I decided to write that with a common denominator here. So I multiplied by the denominator top and bottom. That's just multiplying by 1. So I get, this is a fraction, and then I can add those two, and I get 3x plus 6 in the numerator and 2 square root of x plus 3, which is 3x plus 6 over 2 parentheses x plus 3 to the 1/2. Now I'm going to take the derivative of that. Now you may want to pause and check your algebra, see if you get what I get. So find the second derivative, I have to do low d high minus high d low. Now I'm going to take the half, and that's going to be that to the negative 1/2. Take the derivative of the inside is 1 all over the denominator square. And now I'm getting this. Okay, and I'm going to find out where this is undefined and equal to 0. So I set the denominator equal to 0, and I get negative 3 again. And now if I look at this one, if I set this equal to 0, I decided to kind of look at it with square roots. This is 6 square root of x plus 3 minus, and if I put that down back in the denominator, I get 3x minus 6 over the square root of x plus 3. And now I'm going to multiply through by this denominator, and that'll give me 6 parentheses x plus 3 minus, this underline makes sure that I have that in parentheses, and I get 3x plus 12 equals 0, and that gives me x equals negative 4. So I have two critical values, negative 3 and negative 4. Now on this one, remember that the negative 4 is not in the domain. Okay, nothing to the left of negative 3, it's the same function. And I get positive on this side by substituting in to the second derivative some value over here. So I probably substituted in, I don't know, 0. And if you substitute that into the second derivative is up here. So you have to plug it in here. So if you put a 0 in all of this, you will get a positive value. And we would say, no, here I am doing it, putting in 0. I get a positive value. And the conclusion is f is concave up on negative 3 to infinity. And there are no inflection points. It's just always a plus here. It doesn't have any change sign. So that just means that f is concave up on the entire domain, and there are no inflection points. I'll be back for the next problem.